So, last time we wrote some functions. So let's go look at them because I need to warm up. So this is what we wrote last time. Why did we write this? I'm trying to remember where we wrote this require a unique key constraint thing. Oh, it's for insert. Right. Okay. So for insert, we basically require that you get a unique key to insert. Otherwise, it tries to print out this friendly error message. So now what we need to do, I guess, is use I think we need to use friendly find elem to update this. We already have this function, so instead of using no nat, we're gonna use friendly find, I guess, for update. But it's a little more complicated than that. Well, no, this isn't upsert. This is just update, so it has to exist. Okay. So let me look at Freeman hosting with 2 chatters. How's it going, 2 chatters? And hello, new viewer. How are you today? Yeah, so that goes into constraint. That's basically it. So okay, I think I can do that. So here we just need to do friendly find elem. And how does this work? Takes a function name. Oh, update. It's a symbol, so just a type level string. It takes a key and a list. Or not a list, but okay. Oh, am I just supposed to use? Where am I using friendly? I'm not even using it, so how is this useful to me? I guess I'm supposed to use it here. Or am I supposed to write require key exists? Not sure what I'm supposed to write. If I write require key exists, then for update and delete, I can just. Okay, let's try that, because I think I'm doing this wrong. So this needs to go back to what it was. Just this for now. So we need to build type family like this one. Okay, and then we need a result to just find the element. Not really 100% sure what I'm supposed to be doing here. Should I give myself a hint? I don't think so. Let's try it this way. So when you run an update, it shouldn't just be a known nat. It should be that the key exists. So we're going to require that the key exists. Let's try doing that. So it's going to look something like this. So we're going to have a result, we need a key, and we need a TS. Because the result needs to be a Boolean. So then we're just going to write this function. If it's not super clear, I don't really know what I'm doing. So I'm kind of just learning. But you know, we're going to try and figure this out. We don't need this. We just need TS. Key TS equals void. That's not technically void. That's empty constraint list. What's up, Lumi? How's it going? Okay, so then we just emit like a type error. Okay. And the other thing we need actually is we want the name of the function that we can print it to the screen. So we'll do that like the friendly find element up here, like the func name there. So we'll make that the second argument, I guess. Okay. So, and really, well, okay, so attempting to oh, I see why I put that over there. Okay. So attempting to use yeah, it actually is extensible record types. So this is an open product so that you could have something similar to I'm not dropping any frames. I'm at 3K bitrate and 60 frames, so it's not on my end. But at least, oh, while I'm typing. I mean, I haven't dropped any frames. Oh, I see what you're saying. I think I can see it. Can I see it on my screen? I see what you're saying. I see it in OBS, but I don't see it on my screen, so I'm not sure what OBS is doing. I don't really want to mess with that too much right now, so let's ignore that. But sorry about that. I don't know what to do about it, but I can see it over here. Yeah, unfortunate. Okay, so attempting to use update with a key that does not exist. Product with key Okay, so it's going to say something like attempting to use update on an open product with key and then the key. However, the open product does not contain such key. Has type. Okay, so I think that's the function we're looking for. I'm really annoyed by this because I really don't know how to fix it at the moment. I mean, I guess really the only thing I can do is like try and update OBS or restart the computer, which seems like an absurd waste of time considering I've already started. But if it's really that frustratingly annoying, I mean, I can do that. I'm trying not to. Ah, great. Literally the only thing that's changed is that now I have another disk in this machine with Windows on it. That's the only thing that's changed. I did update recently, so maybe it updated OBS and it has this visual glitch all of a sudden. I could delete the scene and recreate it as well, but I'll try and do that off stream. Okay, so anyway, what we're doing right now is we're trying to write basically a constraint type such that when you use this constraint type, it will ensure that a key that you request exists in our what is this thing called? I mean, it's our open product, I guess, but it's probably got a better name than that. Yeah, I mean, we just call it our open product, but it's essentially just a list of symbols and values. And symbols, think of like, it's like a dictionary. Like think of like a Python dictionary or something like that. Or even a map would be fine, but anyway. Okay, so we have this require key exists type family, and then I think we need to emulate this. Oh wait, no, we don't. We need a, now we need a unique key filter, essentially, where we just need to make sure the key exists. Okay, so let's write that. There it is. Oh, that's not gonna work. I gotta have P. So, oops. We want to write key exists. We need to take a key and that, and we want to say probably like not null. I don't know what this function is called, so we got to go find it. But essentially, we're going to filter this for the key. We want to make sure that it's something. Oh, yeah, I don't have another one of these open. Hang on. So, first class families Haskell. What should we use here? Oh, we can null and then invert it. So we can just say probably this. Okay, so just for reference, if it's unclear, this behaves like normal function application. Wait, no. Yeah, this behaves like $, and this behaves like a composition at the type level. So if you're unfamiliar with that, then it's gonna look really, really funny. So this is gonna give it false because it's not null, I think. How does this one work? What does null do? Just make sure it's not empty list. How does this work? Right, null just checks for an empty list, yes? So, stack REPL. Oh, right. So unique key is looking for it better not contain the key already. That's right. But in this case, we actually want to make sure it contains the key. So you need to do Joppy. Thank you for following me on Twitch. Really appreciate that. We're getting very close to our next follower goal, so I really appreciate that. Also, some of the folks that were around last time also followed, and I didn't notice it. I think it's Zenoviac. It's either Zenovia C or Zenoviac, I'm not sure. On native, and it's L3OL. So I'm gonna say ha 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 OL. That's gonna be their name. How are you? Are you a Haskeller or sort of just interested? Tell me what you like to do. As long as it's not vulgar. Please. Haskell, wonderful. Have you ever done type level stuff like this? It's pretty wild. Yeah, so this should be fine. Because we want to pipe this to null and say, you got burned on it for a bit. Okay, cool. So hopefully you've seen stuff like this before, and this isn't as crazy it is to me. I'm having a really hard time understanding completely this chapter. It's really, really tricky. There's just a lot. I mean, it's like a lot of moving pieces from the book all put together at once, and it's just tricky. I mean, that's what it is. Okay, so this better not return an empty list is basically what this is saying. So we're going to say, give me a non-empty list. I'm going to make sure it's non-empty by flipping the sign of null. I wonder if I can write something like... Haskell's awesome. Right, so all I'm doing is composing these functions now, but at the type level, and then applying it to this. So, like, this is wild stuff. I might not even need these parentheses. I do. Clearly, we're associating to the right, so parentheses start getting added the wrong way. I mean, that's the only way that doesn't work, right? Okay. So now we have key exists and require key exists. So we can write our constraint. So our new constraint for update is basically require key exists. Give me a second. I gotta go look at the other one. Yeah, eval does that thing and then right. Okay. So I'm gonna go with QED. Thank you so much for the follow. I really appreciate that. One person closer to 100. Maybe we'll get 100 today. That'd be kind of cool. I have no idea if that'll happen, but it would be cool. So in here we need to eval, and then require key exists takes that true or false, which we're going to get back. We're going to give it a function name, which is update, and we're going to give it a key and the list of essentially the dictionary. I'm just going to call it the dictionary from now on. It's not a dictionary, but it's going to be easier to discuss if we just call it the dictionary. It has this type, right? Just so we're all clear. That's the type. And then in here, we need to evaluate key exists of key T, no, of just key TS, I believe. So what is this complaining about? Oh, right. And here is where we actually need the friendly find. I see. Okay, because we've gotten rid of our no nat requirement, we can no longer use this find elem. So we need to use the friendly find nat instead with this. So this no longer becomes no nat. It has to become what? I guess. Wait, why does this thing have to take func name? What is func name? Maybe I should get rid of that. And we gotta get rid of this. I'm gonna put the func name in the other things, so I can't really use it here. And then I guess here, you write friendly find lm key. Oh, but that's a value. I think I need to. Oh, we are working on chapter 12 right now. QED. Yeah, it's called custom type errors. So basically, you can write these helper functions to essentially make your type errors a little easier. Yes, yeah, and Jappy brings up a super great point. For anyone who's like not super into Haskell yet, you don't need to know how to do this unless you really want to become a hardcore library writer. Like that's really the only time you need this kind of stuff. We don't do stuff this hardcore every time, so just be aware that I'm doing this for my own musings and nothing more than that. So just be. No. This book has nothing to do with short-term productivity. That is yes. It is strictly about for the long term, I would say it's, I don't know. I mean, it depends what you want to do. So for me, I might never use this again, honestly. I don't know. I hope that I get to use it again because I do think that it's really fascinating. And I'm happy that I'm getting the understanding of using it. But also, I'm not convinced that I'm going to use it in the future. You need to bear with me for just a second. I gotta go get some more water, and I need to change this shirt. It's too hot in this bedroom. So give me a few minutes. I will be right back, I promise. Okay. Put her up there, and we're back. Sorry about that. It's really, really hot in my house. It says it's 77 out there. We turned the air conditioning off last night, so in here it gets a lot warmer. Forgot my water. Shoot. All right, we're back. Thank you for waiting. Okay, so I think actually what we need to do is write a new one of these, probably. Wait, no, doesn't this do the same thing? We just need to put... There we go. And then this becomes friendly. Thank you, Haskell type checker. By the way, I didn't even explain who I am or anything to the new folks here. So just for reference, if you're curious, my name is Barry. What I basically am trying to do is learn Haskell on Twitch in front of all of you. And this can be deep stuff like this, more shallow stuff. We're doing like sort of just generic learning kind of tasks like the programming katas. We're going to start contributing to open source. So we're going to do as much as we can on the stream. And, you know, I'm trying to build just a small community of folks that are interested in doing the same thing. So if you are interested in hanging out and working on Haskell and learning, you know, by all means, come hang out. We'll be here. Okay, so, oh, not dot. I think we need another constraint here for find LM. So actually, does that just imply? Nope, it's just a list of, hang on, let me put this here. Here. Yeah. Boop. Oh wait, I see what you're saying. I'm sorry. It is a vector. That's the kind. Yeah, it's a vector. My apologies. I understand what you mean now. I was saying it incorrectly before. Okay. So then what would be here? Known nat friendly find lm key TTS. Oh, I'm an idiot. Oh, it's just key TS. So then this compiles. This looks wrong though, doesn't it? First, the styling's wrong. So let's fix that. I assume that that's how you'd style this, but this seems overkill now that I'm looking at this. Because we really only need this friendly find LM, don't we? We don't need require key exists, do we? Like this is overkill, right? Because I'm just going to use friendly find LM to cause the error to trigger. So I just really need to extend friendly find LM to say something like update. Yeah, that's what we're going to do. The good news is that I think that this is I'm understanding what we're doing now a little bit better, so that's good, but what we're doing is just not correct yet. Okay, so let's back this out, and we'll start here. Friendly find LM. We'll put this back. So wait, but how do we deal with that here? I don't understand how we deal with that here. Because friendly find LM if I give it the function name, I need to pass it the function name. I guess I can just put something in here. Like, okay, well, let's try it. So let's do this. So we got func name. Then we're say the key is not present in this open product. But we probably need more than this. So it's probably really like using the function with key is not allowed. The key must exist in the... I know you can't see what I'm writing, but it just says the key must exist in the open product. Let's put that on a new line though. So doot $$ text test. The key must exist in the open product. The what is it called? We've used this before, like find something. Show type, lookup type. Show type, lookup. Where'd that go? It just had it. There it is. Key TS. Wait, no, that's not gonna work. We need to show the whole thing. I think it's down here. Oh, maybe it's the right thing. We'll read this after, but I think it's something like this. And then here, I'm not exactly sure what we do. I think we've just put a F here, but it doesn't know how to get F. So do I just put it here? Maybe. It seems okay. Now, this lookup type is not really what I want, is it? Because I really just want to show type TS, probably. Can I do that? Maybe? Not sure. Because we can't look up a key that doesn't exist. What I suppose we could do is filter the keys. Well, not filter them, just get them. I think we can do that. So type lookup keys ts kt equals map first ts. The available keys are keys ts. I don't hate that. That could work. So then findLM passes this thing. So here we just need to write get and then we need to require key. Oh wait, no, we don't need this anymore. We're getting rid of this. And we don't need this anymore. And we can get rid of this. We need to put update here. Oh, and findLM. Wait, how do I? Yeah, how do I deal with this? Can I just do? How do I promote this? Can't put an ant in front of it, can I? I can. Wonderful. Thanks, type applications. At least I think that's where that comes from. So we can do at get. This is pretty sweet, actually. We never get a lot of viewers when we do this, but I honestly find this really cool. Maybe because I'm not explaining myself well enough. It's really hard for me to explain my train of thought because I don't fully understand the end goal sometimes. Also, I did walk away from the computer for quite a while. It's probably not helpful. So this becomes friendly findLM, delete, and then down here, all we had to do is change this to at delete. Right? Beauty. For upsert, we've already handled this problem, so we don't really need to do anything. This is really useful. I mean, like, can you imagine just writing? Oh, we gotta go fix this as well. Can you imagine writing this stuff for folks and like just giving them actually convenient error messages? Like, that's awesome. And sometimes the error message in Haskell are not particularly useful. Oh, nice. Okay, so you can do something like this in Scala as well. I got you. I understood that actually. Sometimes I don't, but thank you for clarifying. This is sweet. Let's see if it works. Okay, so oh, that's good. I mean, I think like encoding functional programming in Haskell is just generally cleaner than Scala, right? That's like a pretty general consensus. You can do it in Scala. You can do pretty much everything you can do in Haskell. It's just a little harder. I'm not sure what this is complaining about, but it doesn't even matter because this is like in our lib function, which we're not even using, so I'm not too worried about it. And I'm pretty sure that we already have... Oh, I was playing a bunch in the REPL, so my history is going to be really dirty. So we got to figure out how to do this again. Okay, so we need to build like a null. So we're going to say like A equals null. I think? No. Nil. I think I called it. Yeah. So that's an empty open product, right? So now we should be able to try and call get, right? Which is this crazy wild thing. But what it takes is a key, which doesn't exist for reference. So we're gonna write get, I think it's key. It doesn't matter what it's called, hello. And the open product is A. Using the function get with key. Oh, that doesn't show hello like we want it to. The key must exist in the open product. The available keys are basically empty list. So, I mean, the shape of this is obviously terrible, but the general idea is working. This doesn't work. Why doesn't this work? Okay, so what if we... hang on. I don't remember how to do this. Think val... Oh. Yes. So... the value would go here, which I think would be like just 1. A key. Oh, I have it backwards, I think. No. Key. Do I need an ampersand here? Yeah. There we go. Okay. Sorry, I need to promote this to the type level. That's the problem. So now we have a B, so we should be able to write get hello. Oh, sorry. Oh, so before we had... Wait, no, that worked before. I'm not sure why it didn't work here. We'll try again. Get key from B. Nice. Ah, that was the error before, actually, because I wasn't promoting this correctly. Right, you can see it with key word is not allowed. The key must exist in the open product. The available keys are hello. Well, wait. This is the wrong first. I wanted just this. I don't care about this. Didn't I write map first? I'm a little confused. Oh, I know what this is. I didn't put an eval. That's the problem. I need an eval. But generally this is getting there. Where is this code? Lookup keys. So here I need to eval this. Otherwise I don't actually get what I want. The other thing we need to do is put these here, because it's supposed to be on the next line. But let's see, what does this look like? That's probably fine. Okay, so now we can create let's call it empty, and then we can try and get key hello empty. Using the function get with key hello is not allowed. I should write is not valid for this open product. The available keys are. That would probably be a better error message. But anyway, we get the point. Now we're getting what I expect, this here. So let's make B again. So with one entry. Oh, empty. We'll just strictly call this hello, and then we'll write get key at world hello. What do you think? I think that's pretty useful. I mean, again, the error message kind of sucks, but like, I'm not that worried about it. So what if we use delete? I think it should look pretty much the same. Is that the right name? Or do I need... Let's see if this changes anything. There it is. Although it doesn't evaluate this for some reason. Something about delete is different than get. I'm not sure I can explain that. Let's go look at the difference. Well, I mean, what is the difference? Looks the same to me. Not sure why it behaves differently. I'm not sure. I mean, it clearly has something to do with the fact that I need that flexible context thing, right? So if I set context and then try and get key, a key that exists, that works. If I try and get world, do I evaluate? That works. So if I try and delete, that's very strange. I can't explain that. What if I try and update? Do I get the same error as get, or do I get the same error as this? Huh. Oh, well, these aren't even fully applied, are they? This, wait, what? Takes? Wait, what? Why does it take an f of t? I think there's an extra f of t in here causing the problem. Delete. What do we need this for? I mean, we can't possibly need this, right? Well, that doesn't work. I wonder why that was there. Did I copy this? I feel like I didn't, but... Oh, this is correct. I need this here. I need that there. There we go. That's correct. I don't understand how that type checked, but okay. So let's try this now. I think we just fixed delete and update for that matter. Let's try that real quick. So we need our hello, and then we'll try and delete key at world from hello. Perfect. There we go. Okay, we fixed that bug. It was basically not fully applied. So it was giving us this strange error, and also we needed flexible context. So maybe that's something that I need to keep in mind. My little cat's sitting over there. He's being real cute. Okay, so then if we try and update, we should get the same error essentially. So it gets a key, and then we need to have a maybe. So we'll try and put a 2 in there, and takes a key, an f of t, and this. So we might need this. Let's see. Aha! Here it is. This is a bonkers error. Could you imagine showing that? That means nothing. I mean, somebody understands that, I suppose, but I certainly don't. But hopefully this is a little more helpful. And then we should just be able to do this if we change this to hello. Oh, but we can't show it to the screen, right? So we just need to look at the type. Well, actually, no, we don't. We do need to save this, so we'll say updated equals, and then updated. Yeah. Well, I actually don't know how to show it. Yeah, right? Isn't that it? That's insane. I mean, that's exactly what it is. And it's awful looking. That's very hard to parse. I mean, maybe we could, but it seems like a waste of our time. Okay, neat. So, what's next? Oh, we kind of did this actually, because we needed it. What it says is, sorry, where is it? There's a lot of stuff in here. Okay, so what it says is, write a closed type family of kind list of k to error message that pretty prints a list. Use it to improve the error message from friendly find_lm. Which I think is the idea is that it's essentially what we're doing here, but this is not a closed type family. Which one is a closed type family? Is it? It's this one? Yeah, I think. So, okay, fine. I mean, we can just change that real quick to a closed type family, I suppose, and it'll do exactly the same thing, right? So, I don't know why I moved it. So, type family, lookup keys. Wait, why is it going to take a list of k? I mean, isn't this the same thing? I'll look at their solution, but maybe I'm misunderstanding. But like, if you just make this lookup keys TS, should be good. I mean, this really isn't pretty printing the list though, is it? I mean, this is just putting a list in there. Maybe we can make it look a little nicer. So let's call this pretty print keys. Pretty print keys. Change this to actually eval. Kind of annoying, you have to duplicate type level functions to behave like normal functions. Yeah, that's true, but their kinds are all different, right? I think that's the trick. Yeah. There's a name for it, which I'm forgetting. Hang on. I can find it when we talked about first class family. It's called type level defunctionalization. That's what it's called. If you want to look it up, Lumi. Newmade, resubscribe for 3 months. You're insane, and I appreciate you very much. Thank you. Also, hi. Oh, I'm so sore. So here we need map first. I see. And then we want to pretty print keys, and we need to evaluate that. Uh, hmm. So I guess I need to put them together. Oh, maybe there's a like a function for this. No, do that. Go print concat. There's something that says list up here. Yeah, so we can fold them. We probably want to fold them. Fold the list with plus plus or something. Well, it's more complicated than plus plus, but because you want space in between them. Well, I think we can do this. So we could do fold R, and we need a function. Then we need this, and we need empty list. Probably at the type level. Wait, no. Can I not? Well, okay. So No. Can we do this? Right there. I'm very confused at the moment. So I think that this is wrong because it's supposed to produce an error message. And I'm supposed to use this to help me. But I don't understand how. I probably wrote friendly find LM incorrectly, which is why this isn't working. I'm gonna peek at the answer because I don't see how I write this. I don't understand what I'm doing at the Interesting. So, hang on. Okay, so essentially he's not using Foldar. Okay? I'm not 100% sure why. We have a list of strings. Sorry, a list of symbols. Do I need to make that clear? I don't think so. And then we're explicitly writing these. Oh, I see. I see what he means now. Okay. So basically, we're just explicitly doing custom error message, show type A. Does this make sense? I get it now, it's just kind of hard. It's always hard. So we're gonna show type A. Okay, and then you need to, I think you're right. You just write pretty print keys. Eval. All right. So essentially, you explicitly pattern match. I'm not sure why the fold doesn't work. It's, oh wait, it's probably because I'm doing, well, I was doing the fold wrong. Let's see if I can do it with fold. Now that I understand the idea. folder pretty. I think you were doing the fold inside the eval. Yeah, I think you're right. I need to map. I think it does. I think it does. So we're gonna write fold R, and then we're gonna get, the only thing is to create a lambda, I actually need to write some extra code. So hang on. I want to see if I can do this because I think that I can, and it would be pretty cool if I could. So what is our thing? Our starting point is going to be text of empty list, right? That's our accumulator. And then just KS, yes? So what we need is a function in here that produces, so we could write like const well, no, you can't write that. You gotta write const, assuming it exists, and then dot with show type. And I think that would work, assuming const is a thing. It's not. Const fn. Oh. Is it the other way? So the const function is going to take an a and a b and give me an x of a? No, because that's x of a. That's not going to work. Oh, wait. Hang on. Spelling error. Okay, now we're going to see the right error message. Yeah, I think it's supposed to be the other way. Const. What if we try just... Wait, no, that's not going to work either. I think I need to write a special function. So, hang on. Let's fix this. You can write type level lambdas. We're going to get... Essentially, the problem is... So we need a lambda like the following. So we're going to get a value and an accumulator. And did I write equals last time, or did I actually write arrow? I don't think I can write this, but anyway. And then we need like show type val plus plus Or not plus plus, this. Maybe I can write this. Hang on. I don't think I can, but this is what we need to write, so I might as well write it here. Show type val yeah, and this doesn't work because you can't write lambdas like this at the type level. So what we need to do is go down here somewhere and go fix that. So this is how you write them. And then we need this. So we need to call this, hell if I know. So our folder is going to take an A and a B and produce an R. No, it's not. It's going to take an A and a B and produce an R. To define folder, A, B equals eval show type A B. I think this is right. Parse error. Does it need to go up here? Oh, duh. I don't know what this means. I want to see the whole error. It may help. Maybe it's supposed to be maybe. So the error message, it embeds seemingly this exp idea, this exp eval idea. So maybe this works. Wouldn't it be cool if it did? What? Do I need to eval the whole thing? Neato. Okay, so because I guess because we're producing an exp error message, I do need to evaluate it up here. So let's see if this thing works. It would be pretty cool if it did. Literally have no idea if it's going to work though. Who's excited? I'm excited. So we need this. So we're gonna insert just one key in here. Well, let's insert two, I guess. Okay, so a few people hopped in, so let me just explain what's going on here. My name's Barry. I work on Haskell on stream. We basically have a book in front of us called, right now, Thinking with Types. And essentially we're learning type level programming in Haskell. So that's what we're doing. And right now we took some code. We were trying to understand how this exercise worked and we didn't. So I looked at the answer, and instead of, usually what I do if I look at the answer is trying to extend the answer. So like I really wanted to try and use a fold instead of just using the explicit recursive implementation just to see what happens. So that's what we're going to do. Hello. Okay, so now we have this thing called world with two keys in it, hello and world. So this thing is supposed to emulate essentially like a dictionary in Python. That's kind of the idea. Except the difference is that our dictionary operates entirely at the type level, which is pretty wild. So, well, it's not entirely at the type level. That's not correct. When we're doing all of these updates and inserts, things are happening in real time, but the types are all computed at compile time. Every time we interpret this line, we're recomputing the proper types on the fly. Okay, so what did we want to do? I guess we can just try and delete one that doesn't exist, right? So key at foo world. Well, it kind of works. It looks terrible, but we really want like commas between these. And also, did we just not add a space? This is actually a way to emulate structurally typed records in Haskell. Structurally typed records. I don't know what that means. I guess it's, yeah, I mean, it's like the proper term is open product, right? I think that's where we're going. Maybe. So something is wrong about my folding function. And I think I know what it is. Because I didn't put a space. Or anything, really. Where is it? Called folder. Yeah, I just concatenated the things together because we wanted to see if it worked, and I totally forgot to change anything. So we're gonna put commas between these things, and that's probably it. I see no reason to do anything else. Let's do that. So, okay, so what we had before, for reference, well, to be fair, I got this from the book, is this code here. Okay, so this is like a standard recursive implementation for the pretty print keys function in this case. That shouldn't count your sub as a sub because you resubscribed. I really hate the way this works. So we did get our, like, I think, yeah, so we should only have 5 subs right now. It'll probably reset to 5 for the next one. I was just thinking about that, but it's fine. I can fix it later. Well, I can't fix it, actually. It's a feature, if you will. Okay, anyway, here's the traditional recursive solution. What we wanted to try and do is convert it to a fold solution. So what you have to do is write a type level lambda. And to write a type level lambda, you need the following things. You need a data type to describe the lambda, and it's going to return some kind of exp. Although I guess it doesn't have to, does it? We just need to get the thing. Anyway, I'll get back to that. So you can write foldr with your folding lambda at the type level on your accumulator and then your list, and then put everything together, okay? So what if we do, wait, this complains though, doesn't it? That's the problem, is that complains. But can we put an eval here anyway? No. We cannot. Okay. So yeah. So there we go. So there's your type level lambda and a fold use, which is sweet. We can get rid of that. And then our function is up here as such. And we're done, yeah? So let's put hello world. I will read that in a second. And then we'll try and delete foo from it. And we get our keys are world and hello. Oh, well, that's not right. We really want fold M here. That's the problem. That's what we really need is fold M. Okay, let's... Because it's basically putting that empty space on the right. That's the problem. I don't think there's like a fold M equivalent. Let's find out. Unfortunately not. I totally forgot about that. Because we really need that to be an empty list, but it can't be an empty list. Yeah, this is a little trickier, unfortunately. Oops, I didn't mean to delete that. That's okay, it's still kind of cool. It doesn't work right, but let's leave it alone. I'm not that worried about it. Okay, so the last thing is, what happens when you directly add a type error to the context of a function? I don't know, what does happen? I assume that we're going to have a type error. Next. This should trigger always. Yes? Okay, I need to read that from Lumi before I forget. A. Foo equals undefined. Okay, let's read this from. So structural type just means that if two types have the same structure, they're equal, which allows you to describe data structures without coupling on nominal types. allowing a lot of interesting kinds of composition from a modularity point of view. It being open then allows you to represent extension in a transparent way, further reducing coupling. The first part makes sense to me, like the fact that you have structural equality. The other part is a little harder for me to parse. There's just some terms in there that I don't fully understand. Someday I will. I hope so. You guys have just done this a lot more than I have. It allows you to write two modules, A and B, which are compatible but don't depend on the same types. Oh, okay. I think I see what you're saying. It's not super obvious to me when that's useful. I guess I would need to come across a situation where that's necessary, right? That's the key for all of this stuff. Do you know of an obvious example, or a relatively obvious one that you could point me to on the internet that I could look at? Because I'd be willing to read it. Okay. We'll let Lumi do this, or do that, hopefully. Okay, so the only other thing that the last exercise was, what if you just embed a type error in the constraint, and very clearly it will never compile, right? Because the function will always have the constraint that it's a type error. So you'll get the error, this will always trigger in type signature, this is always the second thing, and it will just never compile. Okay, I see what you're saying. So you're trying to purposefully link two things such that, if you change one, the other one breaks on purpose. That way, if you change A, B must be changed. That's what you're saying. Okay, I think I understand. But that's the point, right? Like, we're trying to enforce safety in not just our types, but our couplings, if you will. I see. Okay, so I got you. The idea of using this is to relax that constraint. I'm reading the implications backwards. Oh, that's not what I want to do. So this will never compile. Will always emit the type level error. Okay, so we are done chapter 12. That was a hard chapter. My brain is sufficiently melted by that chapter. Okay. What time is it? Okay, we got a half hour. I might be able to get through something. 13. Generics. Now, I think I've used these before. Not 100% sure. Probably not to the extent that we're going to use them here. Rich Hickey, the Clojure dev. Yeah, I know that. describes this very problem, although articulated in a different way, as his major problem with strictly typed languages. And yeah, it's present in Java, C#, F#, Scala, and Haskell unless you work around it. I see. So he that's why he's so gung-ho about dynamic language. Because I know that's like his thing. Wonderful. As usual, everyone bow to Lumi for being awesome and very helpful. Thank you so much. It took me a while to get that, but you explained it very, very well. Ugh. Okay. We gotta clean up this, and hopefully we can actually write some code. I can do that faster. I should, but I didn't. Allow Eric's. And then we also should update this to make sure that our GHC ID is compatible with what we're doing right now. And then we are done. Okay, so when writing Haskell, we have two tools in our belt for introducing polymorphism: parametric and ad hoc. You guys want to meet my cat? I think some of you have seen him before. Okay. This is my crazy kitty, Andre 3000. He is very antsy right now. Yeah, Lumi is the man. Do you agree? Huh? You do not want to be up here right now. So anyway, that's Andre 3000. He's super cute. Or 3 stacks, as Newmaid likes to call him. All right, so parametric polymorphism gives one definition for every possible type. Think head, list of A to A. It's what you get when you write a standard Haskell function with type variables. This flavor of polymorphism is predictable. Newmaid says hi, by the way. He's chasing bugs. He's given up. Ad hoc polymorphism, like its name applies, allows us to write a different implementation for every type, is made possible by type classes. But for our purposes, there's also a third category, a sort of no man's land between the parametric and the ad hoc, structural polymorphism. Structural polymorphism is ad hoc in the sense of being different for each type, but it is also highly regular and predictable. It's what's colloquially known as boilerplate. It's the boring, uninteresting code that is repetitive, but just different enough to be hard to automate away. While structural polymorphism doesn't have any formal definition, it's the sort of thing you recognize when you see it. Okay, cool. So eq, show, and functor instances are good examples of structural polymorphism. There's nothing interesting about writing those instances typically. And you have to write them over and over. The tedium of writing that's not what they were saying, I was just kind of commenting out loud. The tedium of writing boilerplate polymorphism is somewhat assuaged by the compiler's willingness to write some of them for us. Consider the eq type class. While every type needs its own implementation of equal, these are always in the form of, here, I'll write this out even though it shouldn't compile, I suppose. Why is this F not? I'm gonna have to comment this out, but Okay, so anyway, if you're, I'll comment this. So all something like this. So essentially, the point is there's no creativity involved in writing an eq instance, nor should there be. The same data constructors are equal if and only if all of their components are equal. Structural polymorphism is mindless work to write, but needs to be done. In the case of some of the standard Haskell type classes, GHC is capable of writing these instances for you via the deriving machinery. Unfortunately for custom type classes, we're on our own without any direct support from the compiler. Yeah, there's new machinery, the deriving via stuff from, I think that's, what's his name? Iceland Jack on Twitter. I think he was the one that wrote that. He advocates for it heavily. Did he write it? Does anyone know that? For sure? I think he did. Using GHC generics, we're capable of writing our own machinery for helping GHC derive our type classes all in regular Haskell code. Recall that all types have a canonical representation as a sum of products, that they can be built from ethers and tuple operator. For example, I like for example. We'll write a custom maybe because we don't want to screw that up. It's weird writing the ticks on the right now because we've been writing them on the left so often. So we have two canonical. So I'm just putting this here for reference. We're going to use the regular maybe type when we work with this. Although I suppose that's probably not necessary at this point. Oh. From canonical, write a equals just a. Okay, so essentially these are the isomorphisms between these two things. To canonical and from canonical convert from maybe a to either void a, unit a, right? Unit a, apologies, without losing any information. This witnesses an isomorphism between the two facts. Why is this an interesting fact? Well, if we have a small number of primitive building blocks, we can write code that's generic over these primitives, combined with the ability to convert to and from canonical representations, we have the workings for dealing with structural polymorphism. How can such a thing be possible? The secret is in the derive generic extension, which will automatically derive an instance of generic for you. So we can probably just look at it. It's probably in GHC generics, info generic. My goodness. Okay, so it's a little different here than in the book, but it's basically the same. So you have this type family rep A, which is a type to type or star to star in this case. I don't remember exactly why this changes things, but it is what it is. Then you have a from function that converts an a into the representation of a with x, whatever x is. I don't assume we're going to find out what it is. And then you have your to function. So it gets you from one representation to another, I suppose. The associated type, this is now a closed type family or an open type family. I don't remember. I don't remember the syntax difference, but anyway, corresponds to the canonical form of the type A. Canonical form of the type A. Notice, however, the kinds. While A has type, this A has type kind, or star in this case. I said that backwards again. Has kind type. Rep A has kind type to type, or star to star. Somewhat confusingly, their implied directionality might, I'm reading from the wrong place, apologies. We will investigate why this is the case in the moment. Great, because this doesn't make a ton of sense yet. The functions from and to form the isomorphism between A and rep A. Somewhat confusingly, their implied directionality might be the opposite of what you expect. From canonical to representation. Yeah, I suppose that's fair. I guess that's kind of backwards. To converts to, from converts from. Okay, and then we can look at kind rep bool. Oh my goodness. Metadata bool. This is a little different than in the book as well, but kind of the same. Quite a mouthful, but at its heart, the interesting parts of this are that and U1. U1 and this are apparently the interesting parts. These correspond to the canonical sum and canonical unit, respectively. Okay, so let me get out of this and write in here. So if I sort of parse that out, you end up with something like this. I'm going to comment this out because it's not valid Haskell code, but weird. So comment this, and then we definitely need to write a comment here. So okay, so it says we can see the gentle shape of bool peeking out, right? So remember that info bool is data bool. So true and false. So it's a sum type, something like that. Oh, I'm missing a set of dots, I guess. The whatever this operator is called, type is the canonical analog of the var that separates data constructors from one another. And because true and false contain no information, each is isomorphic to the unit type. As a result, the canonical representation of bool is conceptually just either unit, or in its GHC generics form, what garbage unit plus garbage unit. It's obviously not garbage, but it's stuff. Okay. So now with that in mind, let's talk about the other stuff. So we have a D1 and a C1. So D1 and C1 contain metadata about bool's definition in source code as promoted data kinds. D1 describes its type, its name, where it is defined, and whether or not it's a new type. So its name, where it's defined. There's something else here which I don't know. Oh, its name, where it's defined. Where it's defined, I guess, is both of these. And then whether or not it's a new type. It's not a new type, so it's false. Okay. C1 describes a data constructor. Its name, its fixity, and whether or not it has record selectors for data. So there's no record selectors. I'm not sure exactly what this means. Prefix I. Fixity. Does that mean prefix 1? As in it's star? Or its kind is star? Structural polymorphism that is interested in any of this information is capable of extracting it statically from those data kinds and code that isn't what? That's not proper English. And code that isn't can easily ignore it. I'm not sure what that's supposed to say. Normally it's written well. Operator fixity. What does that mean? Why do I not know what that... Do I know what that means? Maybe I do. Oh, thank you. Over here. Oh, I get it. Fixity. Okay. Prefix operator versus infix operator. I got it. Thank you. Fixity. Gotta memorize that one. It's not something I say very often, right? I usually just say, well, I do say infix, using infix or prefix notation. I've said that before, and that describes its fixity. Anyway. Okay. Unfortunately, we've run out of time, and there isn't really any exercises for a little while. But we're going to talk about how we define, how we do this, how we build something for generic and derive generic code for, I think, equal. And then we'll do, there are some exercises here where we're going to provide a generic instance for, for the ORD class. And then we're going to use GHC generics to implement the function ex nihilo. I'm not sure how to say that. Nihilo? Nilio? Yeah. This function should give a value of just A if A has exactly one data constructor, which takes 0 arguments. Otherwise, weird function name should return nothing. Okay? So that's what we're going to do next time. But that will be next Sunday. That's not going to be the next time I see you. The next time I see you will be on Tuesday, and we're going to work on Book of Monads. Okay, so generics are really nice, but they can have some overhead potential compared to macros, template Haskell. So it's hard to get them right, I think. I have had bad experience with the Scala equivalents. Interesting. Well, we'll see. Maybe we'll learn something about the Haskell ones. I mean, have you used the Haskell ones enough? Or not enough, that's not the right term. Have you used them and compared them to template Haskell, or have you only used one or the other? Does that make sense? At some point, I definitely want to play with template Haskell. And I don't know if it's in this book. I don't think it is. Oh, wait. Let's see if you say anything. No, we're actually pretty close to being done with this book. There's only 3 more chapters left. I don't know how heavy